Hi, myself Jaganath. I learned a new course in Skyfi Labs. The course name is Machine Learning using Python. So far, I learned linear regression in Python. We have we have performed a price predicting model in Boston housing data that is present in a SK learn data set. First, we need to import various machine learning libraries such as NumPy, Panda, Matplotlib to plot graphs, and sklearn library has functions like mean square error, min max scalar, and function that splitting the data. And we also imported IPython to display HTML for an animation purpose. First, we need to load the data called Boston data. The Boston data has 14 attributes, but we are using that only 13 attributes. The 14 attribute is median, and now we need just a data frame object product in Panda library to assign the features columns and the Boston data in the features and Boston data frame, and then we need to print it. The result has 506 rows and 13 columns. There are that is 506 values and 13 features. Now assign the target which the price will have a predict on our prices. As we also use the data frame object present in a Panda library to assign the target column, and we need to check and print it also. The target also have 506 values. The minimum and maximum function you used to print the maximum and minimum function in the target. Now we just need to concatenate the features and target into a data frame, and we just use the concat function using the pandas in every. The axis 1 denotes column is concatenation, and under axis 0 used to row wise concatenation. So far we used axis 1 for column wise concatenation. We can also define data frame object in to define a count, mean, standard, minimum value of present and maximum value in present to display the particular columns. Now we just need to find the concatenation between the target value and the features correlation. In this way, just to depend rate of features and the target, how to change the features depends upon the change of the target. There are different type of correlation, but we used person and correlation function, and we can also obtain the absolute value of the every attribute in the features. We can just use the matplot function to plot a graph against the features and targets. You can see the bar graph for attributes. We need to normalize the data by using the lstat function, and we lstat, you can see lstat is the highest value in the target. So far we use the lstat function. and we before normalization and we printed the 5 values, and then we will use the target column for y. We can normalize them by using the min max scalar object and create an instant. We can also use the infit transform function, and we used other reshape function because the fit transform function and only allows vertical data. Then we can utilize him by check it back. This is the value after the normalization. And then we need to split the data into a testing and target training data. We taken 80% of the data for test training data, and we taken 20% of data for testing the data. And then we need to define some kind of cost efficient. We have used a mean square error function to define the three functions from the three functions. So there are diff error to define a mean square error, and diff update to update the MNC slots for the linear regression equation. And we defined the gradient descent function, and to which we can train numbers of attributes to the loop. It will check the error every time same updates after the error. If there are less than the threshold, we need to break out the rule loops, and we want to save the values in their same pages. Return the final MNC value for predictions. Here we use the gradient descent function. Keep the learning gradient descent function to give the values. You can see the wall time is 120 ms. We plotted the regression curve which is training data particular value. We can see the slot curve is slot curve for LSTAT function. We can also use the error with the iteration, and you can see the error have a decreasing over the all iterations. And we can also visualize the training phase and the model by using the HTML and func animation functions. You can also see the video how the model will train itself and regulate the curve after coordinating while the MNC changes. And now we can get to the predicted value using the M into X test plus C equation for the linear regression. We can also test the mean square error against the target value and the predicted value, which has 0.017, and that is LSTAT function. Then we just add the testing data in a predicted value in a data frame and show them. You can also plot the scattered plot on the testing data. You need to find a predicted data in a target value. You have to break it and normalize it. You need to normalize the scaling. It will can use the inverse transform function for it, and then after scaling you can just put it back and edit on a edited frame. You can see the target value and predicted value. We can also change the feature into a RM function and you can test it. I changing the LStat into an RM and run all below. You can see the graph for regression curve after training the slot for in the RM function. You can see the curve also is differed. You can see the model how it trained in a RM function. And you can see the mean square error as is to 2 times the LStat function, and you can see the final predicted value. You can also change the features something which affects the target which have minimum rate DIS and shall run all below. And you can see the graph for regression curve is changed, and you can see the error value, and you can see the animation graph. You can see that mean square error has increased again by using the DIS function. This is the final predictor value for DIS function. Thanks for watching.